In this short video, I'm going to explain how the sodium-potassium or NAK pump works and its importance to various cellular processes in our body. So first, what is the sodium-potassium pump? The sodium-potassium pump is a specialized type of transport protein found in your cell membranes. The NAK pump's job is to move potassium ions into the cell while simultaneously moving sodium ions out of the cell. So what is the importance of this pump? In nerve cells, the sodium-potassium pump creates gradients of both sodium and potassium ions. These gradients are then used to transmit electrical signals that travel along nerves. Without this process, your nerve cells wouldn't function. To give you an idea on how this pump works, I will present a simple analogy. Imagine the cell as a big apartment complex, and within that apartment complex is one main door where everyone can go in and out of the building. Imagine that this door is the NAK pump. The three sodium ions present inside the cell or the apartment complex are three roommates who are all schoolmates running late for class. The two potassium ions present outside of the cell are two workmates who just finished their night shift begging to go inside to get some sleep. But there is one major problem. The main door or the NAK pump is locked both from the inside and the outside. Luckily, there is a guard present inside of the complex with a key. Imagine that the guard is the adenosine triphosphate and the key is the phosphate group transferred by ATP to the NAK pump protein through hydrolysis. Since the guard was inside the apartment complex, the three roommates were able to go outside with the help of the key. The key or the phosphate group, once subjected to the sodium-potassium pump, creates a phosphorylated intermediate form of the pump. We can think of this as the main door with the key inserted in it. Once the pump is phosphorylated, it changes in shape. From facing the inside of the cell, it now opens towards the outside of the cell, releasing the sodium ions or the three roommates inside the apartment complex just in time before their class starts. When extracellular potassium ions or the two roommates outside bind to the phosphorylated pump, they trigger the removal of the phosphate group, or in other words, they remove the key from the main door once they were able to go inside the complex. Being too sleep-deprived and tired, they accidentally lock the door again, making this process an endless cycle of two reactions, an exergonic and an endergonic reaction. The exergonic reaction is how ATP releases ADP and one phosphate group through hydrolysis, while the endergonic reaction is the creation of a phosphorylated intermediate form of the pump through the added energy from the phosphate group transferred by the ATP. Without the help of these two connected processes, the sodium-potassium pump and the various cellular mechanism it brings about wouldn't be possible.